Okay, we're now going to move on to Chapter 2, Section 6, dividing real numbers. In the last section, we looked at multiplication of positive and negative real numbers. We also looked at the distributive property of multiplication and combining like terms. Now we're going to move on to looking at division with positive and negative real numbers and look at the distributive property of division. So first let's look at a little bit of vocabulary. The first phrase is multiplicative inverse. Multiplicative inverse is a fancy phrase, but it means exactly the same thing as reciprocal. So let's write that down. So, as I said, they mean the same thing, and you should have learned about the reciprocal last year. Essentially, the multiplicative inverse of 2/3 right here is 3/2, because 2/3 times 3/2, if we multiply the numerators together, we get 6, and the denominators together, we get 1. We get 6, and 6 divided by 6 here is 1. And that is the definition of the multiplicative inverse or reciprocal. It is a number, when multiplied by the original number, gives us back the number 1. Okay, let's look at another example. Here we have negative 1/5. The multiplicative inverse or reciprocal of negative 1/5 will be negative 5/1. We simply flip the numerator and the denominator. When we flip them, multiplying the numerators, we get negative 1 times negative 5, or 5. Multiplying the denominators, we get 5 times 1, or 5, and 5 divided by 5 is 1. Let's take a moment and do some practice examples. Okay, so the reciprocal or multiplicative inverse of 4/7 will be 7/4. The multiplicative inverse of negative 6 will be negative 1/6. Notice that we have to keep the same sign here. If we start out with a negative, the reciprocal will also be a negative. The reciprocal of 1/2 will be 2/1, or 2. The multiplicative reciprocal of 1 will be 1/1, or 1. The multiplicative inverse of negative 5/2 will be negative 2/5. And the multiplicative inverse of 1/4 will be 4/1, or 4. Let's take a closer look at division. But before we do so, I just want to remind you of what we've studied previously when we practice rewriting subtraction as addition. If you recall, in a problem such as 10 minus 6, we could write that as 10 plus a negative 6. Now, why would we ever want to do this? The reason is because there is no commutative property of subtraction, but there is for addition. So, for example, 10 minus 6 here does not equal 6 minus 10. 10 minus 6 is 4, and 6 minus 10 is negative 4. So they certainly do not equal each other. However, when we use addition, there is commutative property of addition. So if we rewrite 10 minus 6 as 10 plus a negative 6, we can switch the order of these terms and get equality. So negative 6 plus 10 certainly does equal 10 plus a negative 6. Both sides of this equal sign equals positive 4. The reason why I talk about this is because there's a very similar situation with multiplication and division. If we look over here closer, we can rewrite every division problem as multiplication. For example, 24 divided by 4 can be rewritten as 24 times the reciprocal or multiplicative inverse of 4, which we just practiced on the previous page, is the flip of the numerator and denominator. So we can rewrite 24 divided by 4 as 24 times 1/4. Now, why would we ever do this? For the same reason why we would rewrite subtraction problems. There is no commutative property of division, but there is for multiplication. For example, 24 divided by 4 does not equal 4 divided by 24. 24 divided by 4, as we know, is 6. That does not equal 4 divided by 24, which is 4/24, or 1/6. 6 does not equal 1/6. However, 24 times 1/4, I can rewrite that as the same thing as 1/4 times 24. If I do that multiplication, I would multiply the numerators. 1 times 24 equals 24. Multiply the denominators. 4 times 1 is 4. 24 divided by 4 is 6. Okay, another reason why we would like to rewrite division is because it really is the only way to divide by a fraction. So let's take a look at what I mean by that. I've got my funny little alien guy here who's taking a closer look with a magnifying glass. Here we have 4 divided by 2/3. Well, how do we divide by a fraction? What we do is we keep the first term, 4, and we change division to multiplication. So keep change, and we flip that fraction to the multiplicative inverse or reciprocal. Oop, I've spelled change wrong. Okay, so 4 divided by 2/3 can be rewritten as 4, and I'm going to write it as 4/1, times 3/2. So we multiply the numerators together. 4 times 3 is 12. Multiply the denominators together. 1 times 2 is 2. And 12 divided by 2 equals 6. So keep, change, flip. This is how we divide by a fraction. Okay, let's find the quotient of 4 practice problems. Remember, quotient is the result of division. So it's a noun, it's the result. Okay, so each of these problems are numbers, either whole numbers, integers, or fractions, being divided by a fraction. So, as I said, we want to keep, I'm going to write this down, keep, change, flip. So, first problem, 10 divided by 5/3. I'm going to keep 10. I'm going to change division to multiplication, and I'm going to flip this fraction 5/3 to its multiplicative inverse, which will be 3/5. If I want to multiply 10 by 3/5, it's convenient to put 10 over 1. I'm going to multiply the numerators together. 10 times 3 is 30. I'm going to multiply the denominators together. 1 times 5 is 5. And 30 divided by 5 equals 6. Next, number 2, we have a fraction being divided by a fraction. First number, keep. So it stays the same, 3/4. Now we're going to change that division to multiplication, And we're going to flip that fraction to the reciprocal or multiplicative inverse. The reciprocal of 1/4 is 4 over 1. So I'm going to multiply the numerators. 3 times 4 is 12. I'm going to multiply the denominators. 4 times 1 is 4. And 12 divided by 4 is 3. Okay, number 3. Keep. 1 stays the same. I'm going to put that over 1. I'm going to change that division to multiplication. And I'm going to take the reciprocal of 1/3, which is 3 over 1. 1 times 3 is 3. 1 times 1 is 1. And 3 over 1 can be simplified to 3. Finally, number 4, 3/2 divided by 6. I'm going to keep 3/2 the same. I'm going to change division to multiplication of the flip, the reciprocal or multiplicative inverse. 3 times 1 is 3. 2 times 6 is 12. And you can leave your answer as 3/12, that's perfectly fine. Or you can simplify this as well to an equivalent fraction, which is 1/4. That would be both the numerator and denominator being divided by 3. Okay, let's now look at what are the signs of a quotient if we're dealing with positive and negative numbers. So the quotient of two real numbers with the same sign, that means both negatives or both positives. The quotient of two real numbers with the same sign, it's just like multiplication, that would be positive. The quotient will be positive. Now, what happens if we have two real numbers with different signs, positive and negative? The result, just like multiplication, will be negative. And finally, the quotient of 0 in any non-zero real number is always going to be 0. Now, what do I mean by that? I mean 0 over any number. Okay, I'm just going to put a here. Any number, 0 divided by a of any number is going to be 0. Now, do not forget, however, that no numbers can be divided by 0. In other words, 0 cannot be in the denominator. For example, b divided by 0 or b over 0. This is undefined. Okay, we can never have 0 in the denominator. Okay, so let's take a look at some examples here. Order of operations tells us we have to work in the group first, so -8 times +6. Well, those are different signs, so that's going to be a -48 divided by a -4. Well, these now have the same sign. They're both negative, so the result is going to be +12. Over here, -56 divided by +7, well, they are different signs. So our result is going to be negative. And 56 divided by 7 is 8. So our result is going to be -8. Okay, let's move on. And now let's take a look at the distributive property of division. So we just studied the distributive property of multiplication. Let's just review that real quick. We can distribute this 6 to every term in the parentheses. In this case, we have 2 terms, and get basically multiply that 6 by all those terms. So 6 times 2 plus 6 times 3. If we look at an algebraic expression over here, this is 2 times the difference here, so 2 times 4x, and 2 times 8, we've got 2 times 4x minus 2 times 8. Okay, now let's look at the distributive property of division. It's really the same thing. Only now the terms inside the parentheses are being divided. Okay, every term inside the parentheses is being divided by this number over here. So we have 21 being divided by 3 plus 3 divided by 3. Over here we have 30x being divided by 5 plus 5 being divided by 5. We can simplify this over here to 7 plus 1, which equals 8. And here, 30x divided by 5 is 6x. 5 divided by 5 is 1. So our answer is 6x plus 1. Okay, sometimes the division may be represented using the fraction bar, such as this. So here we have 24x minus 8 divided by 4. Well, we can rewrite it just the same way as we have up here. We can say this entire numerator, it's a group, so we can put that inside parentheses, is being divided by 4. Again, distribute. This is 24x being divided by 4 minus 8 being divided by 4. Now 24x divided by 4 is 6x minus 8 divided by 4 is 2. So we can simplify this expression down to 6x minus 2. Okay, let's take a look at two practice problems. We have 40x minus 16 in a group being divided by 8. So let's use the distributive property of division. Again, just like multiplication, why would we do this? Because order of operations tells us to work inside the group first. However, inside the group is not like terms. 40x and 16 are not like terms. So we really can't simplify that yet. So that's why we're doing the distributive property over division. So we have 40x divided by 8 minus 16 divided by 8. 40x divided by 8 is 5x. 40 divided by 8 is 5. Minus, and 16 divided by 8 is 2. So this can be simplified to 5x minus 2. Over here in number 2, we have 22 plus 55x divided by 11. Sometimes people like to show that division using kind of these butterfly wings. So 22 is being divided by 11, and 55x is being divided by 11. 22 divided by 11 is 2, and 55x divided by 11 is 5x. And that's how we use distributive property of division.